Okay, I actually found this problem to be quite challenging and took several different directions before I finally figured it out. I put a lot of work on 3 of these boards to save time. First thing you have to realize is that this is the equation of a circle with center at 3, 1 and a radius of the square root of 5. I've showed how to complete the square here to determine that. And now we'll go on to the next board. So here's a picture of that circle with the line y equals kx drawn through the circle. It took some experimentation to figure out that this line will probably hit the circle in such a way that this point of intersection is to the left of the line x equals 3. I actually believe there's another solution where this line y equals kx could also be down in here, and we would have a 90-degree arc cut off by that line. But I'm focused on this solution right here. So if this arc is going to be 90 degrees, I could call this point A and point B. If that arc is going to be 90 degrees, then the central angle that intercepts that arc must be 90 degrees. And what I wanted to do is try to find an equation that only involves k in order to be able to solve for k. So I decided eventually that if I drop this altitude to the line y equals kx from this, what turns out to be an isosceles right triangle, the red one right here, with the green hypotenuse, has legs of radical 5. If I drop that altitude, then I create 2 other 45, 45 right triangles. Oh, and by the way, this distance is radical 10 because in a 45, 45, the hypotenuse is radical 10 times one of the equal legs. And so when I drop this altitude, these 2 green segments right here are radical 10 divided by 2. And then this altitude, because of this isosceles right triangle here that I'll label triangle 1, the legs have to be equal. So this altitude is 10 radical 10 divided by 2. And I decided if I could find this point of intersection in terms of k, that I could write an equation that said the distance from this point to the center of the circle would equal radical 10 divided by 2. So how do I find this point of intersection in terms of k? Well, the slope of the green line, of course, is k. So this perpendicular has to have a slope that's -1 over k. And now the equation of this altitude is using point slope, y minus 1 equals the slope of that line, -1 over k times x minus the quantity x minus 3. And so now I have a system of 2 equations. And if I substitute this expression right here into the other equation, this is what I get. And I went through all of this, isolated the k, you can follow the steps, and saw that this was the equation, the expression for the x coordinate of this point right here. And since y equals k times x, y would be k times this value of x. So the coordinates of this point right here are what you see right here and here. And now I could write an equation that says the distance from this point to 3, 1 is the square root of 10 over 2. So let's go to the next board. Kind of just cut out the pieces that we need here. Here's point 1, those coordinates in terms of k. Here's point 2. The distance between them has to be radical 10 over 2. Using the distance formula, Here's an expression for the distance between P1 and P2, the square root of the change in x squared plus the square root of the square of the change in x squared. And if I square both sides, I get rid of the radicals. 10 over 4 reduces to 5 halves. And now getting this into a form where you can sort of see what's going on takes some work. That's the ... But eventually I ended up with this. And I thought, well, how am I going to find out the values for K? Well, I'm going to use Newton's method. And I actually have, if I share my screen, a Desmos graph that actually implements Newton's method. So here's f of x equals that function, and I want to use Newton's method to estimate the roots. G of x is the derivative of f of x, and n of x is the function that allows us to calculate the next root. It turns out that here's that other possible value for k, negative 0.205. And there's the 1.128. So I'm solving for this root using Newton's method. So I let x sub 0 equal 1, and then applied Newton's method. X sub 1 equals n of x sub 0. And by the time I get down to x sub 6, that looks like the value for k right there, 1.1277, etc. Okay, that's a lot of work. And I'll go one more time to here. There is the value of k that I determined by Newton's method. And here I've actually calculated the angle between this red line and this red line. And for that value of k, I get a value for q of 89.99996, which seems to indicate that indeed for that value of k, this is a right angle, and therefore this is a 90-degree arc. It'd be interesting to see what would happen if we drew the line here with the slope of k equals negative 0.205 and see if we could draw the same conclusions. So there you go.